All right, so the first half of this unit was all about solving a system of equations. And that's great. And that's the theory behind everything. It's going to help us get through the rest of the unit. But now what we want to do is we want to apply our knowledge in word problems, because that's what reality is all about. It's about taking a real scenario and breaking it down into the math so we can actually solve and come up with some kind of solution for whatever problem's in front of us at the moment. Now, there are 5 core types of word problems we're going to see in the rest of this unit. Today, we're going to look at 3 of those types of word problems. Now, a lot of times you're going to see the phrasing on a test or somewhere that says model a system of equations or model the following problem. What it's really asking you to do there is simply create a system of equations. So create the equations from the description that you're given. Now, that is easier said than done sometimes because you have to really know and understand the language. So if you recall, lesson 1.0 helped us kind of break down all the key words to look for to help us break down the problem and figure out what we're actually trying to solve for. So let's start off with describing our goal here. So when we want to solve a linear system word problem. Let's see if this auto text work things here. What we want to do is we want to first kind of define our variables. And to do that, we're going to create 2 let statements. Whoa, that is not doing what I want it to do. I'm going to backtrack that a little bit. Looks like it scrolled up automatically. Let's try again and just use a regular pen. Let's see if this works better. So we want to create 2 let statements. That's a little bit better. And inside of these let statements, we're going to create, after we have these let statements, we're going to use the variables that we've defined there to create our 2 linear equations. Now, the whole rest of the unit previous to this was all about solving a set of linear equations. So whether you're using substitution, elimination, graphing, whatever suits the problem at that moment, use that. Unless, of course, you're instructed to do something specific. So use one of our problems, such as maybe substitution or elimination. Depending on the equations, one's going to be easier than the other, typically speaking, or graphing. Now, usually that's not going to be the optimal choice because it's not always very precise and it tends to take a lot more time. All right, so of course, as with anything, when we want to check our solution, we're going to use a left side, right side check. Nothing new here. So let's look at this first problem that sits in front of us. So the first type of problem is something called a combination problem. So this we usually see this when we have a combination of items and we want to figure out how many of each item we have or some form of relationship between these items. So in this case, let's look at example 1. Sebastian needs to buy some fruit. He needs to buy a total of 32 apples and oranges. So that means if you combine all of the apples and oranges together, we have 32. Now, the key word here is total. So what that is implying is that it is a sum of these items. His dad asked him to purchase 3 times as many apples. So 3 times as many apples as oranges. That means he's got 3 times as many apples as oranges. We got to break that down. Okay. And then our goal is to say how many of each fruit does he need? So when you're trying to do your let statements, remember we're trying to create variables. So the goal here is to define variables that represent our unknown values. Well, the question actually tells us what the unknown values are this time. How many of each fruit does he need? So our let statements are going to be simply let X represent the number of apples purchased. Okay. Which of course means that Y is going to represent the number of oranges purchased. Now what we need to do is we need to come up with some set of equations that model what this description is saying. What do you mean model, Mr. Lane? I mean the equations that represent the math that we're given. So in this case, we see the first one is the most obvious one. We have a sum. A sum of apples and oranges gives us 32. So if we add up the number of apples plus the number of oranges, we get 32. Well, those are our two variables. So that means our first equation is just x plus y is equal to 32. Okay, what else do we got? Well, it says that we have 3 times as many apples as oranges. So apples is represented by x, and it's saying, hey, we have 3 times as many apples as oranges. So x is going to be equal to 3 times the number of oranges we have. So x is equal to 3y. Now our job is just to solve the same way that you've solved in the past. Now, in this case, am I going to use elimination? Not really. Nothing's really aligned very well. But substitution works great because I already have one variable that's isolated. So we're going to sub x into 1. Oh, I forgot to label this equation. This is equation 2. We're going to sub equation x into 1, and our goal is to find y. Okay. So that means wherever I see an x, I'm going to put a 3y. So instead of x here, I have 3y plus y is equal to 32. So that's 4y is equal to 32, which of course means y is simply 8. What does that mean? Looking back at the problem, that means that we have 8 oranges. Okay. So now we need to calculate how many apples we have. So we have a value for y, so we're just going to take this number and substitute it back into either equation. Well, guess which one's the easier equation? Equation number 2. Oops, we'll go over here. So we're going to sub y into 2, and our goal is to find x this time. And if you look at our descriptions, x is the number of apples. Okay, so x is equal to 3 times y. Well, y is 8. So x is equal to 24. So now we actually have a word problem. So our therefore statement is extremely important this time. So we have to answer the original problem using the data that we found. Well, what was the original problem? Was how many of each fruit did he need? In this case, he needed 24 apples and 8 oranges. Okay, so therefore, Sebastian needs to buy 24 apples and 8 oranges. Apples and 8 oranges. So that's a combination problem. So the next problem is the same idea. We have some combination of items, and we got to come up with 2 equations to represent that combination. Okay. So Jesse has 5 more apples than Juan. So if Juan has, let's say Juan has y apples, then Jesse's apples x is 5 plus that y. Okay. So Jesse has 5 more apples than Juan. There's our first piece of information. In total, oh, there's that total word again. That means sum. They have 13 apples. So both combined, they have 13 apples. How many apples do they each have? So there's our unknown again. How many apples do they each have? So we don't have 2 different types of fruit this time. We just have a different quantity of apples for each person. So in this case, let's let x be the amount of Jesse's apples. Amount of Jesse's apples. And that means that y is going to be the amount of Juan's apples. Oops. Now we need to create our equations. So let's do the easiest one first, which is just the sum. We know that if you add both of their sets of apples together, they get 13. So our first equation is just x plus y is equal to 13. How do we get our second equation? We got to look for more data that was given to us. In this case, Jesse has 5 more apples than Juan. Well, if Juan's apples are y, that represents y plus 5. And that is Jesse's apples. So x is equal to y plus 5. Now again, we can rearrange this. We can do elimination. But again, we already have a variable that's isolated, so let's use substitution. Makes life easy. So we're going to take this, and and we're going to sub x into 1, and we're going to try and find y. So that means wherever I see x, I put y plus 5. So y plus 5 plus y is equal to 13. We've got to collect our like terms. So on the left-hand side, we have 2y. On the right-hand side, I have 13 minus 5, which is going to give me 8. So y is equal to 4. Okay. Let me just back that one up a little bit. There we go. Perfect. So we have a value for y now. Let's go back. Oops, not let me write here. Let's try again. There we go. So now we're going to substitute our y value into our easiest equation. In this case, that's equation 2. So we can find x. Sub y into 2 and find x. So the equation is x is equal to y, which is 4, plus 5. So therefore, x is equal to 9. So what that tells us is that combined, we have 9 plus 4, which is 13. Oh, that math looks pretty good. So therefore, we can say Jesse has 9 apples, because that was x. X represented the amount of Jesse's apples. So Jesse has 9 apples, and Juan has 4. Four apples. Okay, so those are our combination problems. And those are going to be the most straightforward to recognize because we're just looking for a combination of items and how they relate to one another. Let's move on a little bit. Next type of problem is all about numbers. So number type problems are not about items anymore, they're just simply values. So in this case, we have the sum of two numbers is 25. So we have the sum of two numbers is 25. Okay. 5 times the smaller number plus the larger number is 65. Well, is another way of saying x. So we're saying 5 times the smaller number plus the larger number. What are the two numbers? Again, it's telling us what the unknowns are. It's the two numbers. And we know that one of them is smaller than the other one based on the description here, smaller and larger. So we can say, well, let's let x represent the smaller or the larger number. Let's x represent the larger number. And let's y represent the smaller number. So we can tell this one from the combination problems because this one isn't about items, it's just numbers. Okay, so now we need to create equations. Let's look what we have. The sum of two numbers is 25. Oh, so we just add them up and we get 25. Excellent, that's a nice and easy one. X plus y is equal to 25. We need another equation. Let's see what else we got. 5 times the smaller number. Okay, the smaller number is y. Okay, so 5 times that. So 5y plus the larger number. Nothing's changing about the larger number, so it's just 5y plus x. And that whole thing is 65. Okay, so what do we have here? Do we have a nice simple way of doing substitution? Not directly. So we have choices here. We could rearrange it and do elimination. Yeah, that'll work. Sure, why not? So let's rearrange number 2. We're not changing anything here, so it's going to still be the same equation. So I'm not making a third equation. I'm just rearranging it so the x's line up with the x's and the y's line up with the y's. So this is saying x plus 5y is equal to 65. Okay, so what kind of math do we need to do here? We need to get rid of one of the variables. So which ones have the matching coefficients? The x's do. So, and they're the same size, or the same sign, so we are going to subtract them. So we're going to say 1 subtract 2. That's what we're doing over here. So we have x plus y is equal to 25. And below that we have x plus 5y is equal to 65. Now we are going to subtract these two things. So x minus x, that just goes away. That's 0. 1 minus 5, that gives us negative 4y. Up here we have 25 minus 65. What does that give us? Well, that gives us 40. Yeah, negative 40, sorry. Negative 40. So when we divide both sides by negative 4, we get y is equal to just 10. Okay, so we got our first number. What is y? Y is the smaller number. So that means x better be a bigger number. So we're going to take this number. We're going to substitute it back in. Where are we going to substitute it? Whichever one's easy. Probably equation number 1. So we're going to say, so let's sub y into 1. And we want to find x this time. Okay, so we have x plus y, which is 10, is equal to 25. Bring the 10 over to the other side, so x is just equal to 15. And that's it for the math. We just need to give a final statement. So therefore, we got to answer the original problem. What are the two numbers? So therefore, the larger number is 15, and the smaller number is 10. So that's our first number problem. Let's do another one. So how far down? We'll go there. Okay. So this one is the same idea. Twice the larger of two numbers. So we know we have two numbers again, and twice the larger one of two numbers is 3 more than 5 times the smaller number. Whew. Okay. The second phrase says the sum of the sum, so it means the addition, of 4 times the larger number and 3 times the smaller number is 71. Okay. What are the two numbers? So again, our unknowns are just the two numbers. So let's do the exact same statement we did last time. Let's say, let's let x represent the larger number, and y will be the smaller number. Okay. So now we got to come up with our equations. Now the wording is a little bit more tricky this time, so we have to take our time. So equation number 1. Equation number 1 says twice the larger number. So the larger number is x. So twice the larger number, so 2x. Twice the larger of two numbers is, so that means it's equal. It's equal to what? It's equal to 3 more. Well, more is the same thing as saying add. So 3 more. So we could say 3 plus 5 times the smaller number. 5 times. So 5 times y. 5y. Okay. There's equation 1. We can simplify it if we want. So let's rearrange it and put it in. Let's put it into the form that we're used to, where we have the x and y on the left, and we have our constant on the right. So let's bring this over here. So we have 2x minus 5y is equal to 3. Okay. There we go. And now let's do equation number 2. So equation number 2. So now we got to look at it with the next piece of data. The sum, okay, so we're adding something. What are we adding? The sum of 4 times the larger number. So 4 times x, 4x plus, because it's a sum, 3 times the smaller number. So 3y is equal to 71. Okay, so looking at this, we already have two equations that are pretty close, but not exactly the same in terms of sizes. We don't have the same coefficients, but we do have the same ordering and whatnot. So what we'll do is let's take equation 1, and we want to have the same coefficient. So the only coefficient that really works easily is the x coefficient. So in equation 2, it's 4, but in equation 1, it's only 2. So that means we have to double equation 1. So let's take equation 1 and let's times it by 2. And this is going to be equation 3. Okay? So that means we have 4x minus 2 times 5y, so minus 10y, is equal to 2 times 3, which is 6. Okay, now we actually have numbers we can work with. We have two coefficients that are the same, and they have the same sign, which means we have to subtract. So we're going to do 2 minus 3. So 4x minus 4x, gone. 3 minus negative 10. So that's the same thing as saying 3 plus 10. So we have 13y. Now we have 71 minus 6. That's going to give us 65. Oh, that's nice, because 65 and 13, those things work out really well. When we divide 65 by 13, we get y is equal to 5. Okay, so now we have our first value. We can just take that and substitute it into either equation. Doesn't really make a difference which one. I don't know. Let's substitute it into equation number 1. So we're going to say sub y into equation 1. And our goal is to find x, since we already have y. So wherever we see a y, we're going to put a 5. So we have 2x is equal to 3. I guess, where's my eraser? We'll use the second version of it just to keep consistent here. Sorry. So we have 2x minus 5 times y, which is 5, equals 3. So let's do the math. So we have 2x minus 5 times 5, that's 25, is equal to 3. Now we're going to bring that 25 to the other side. So we have 2x is equal to 28. That means that x is equal to 14. Okay, so we've solved our final problem. We just need our therefore statement. We know x represents the larger number and y represents the smaller number. So therefore, the larger number is 14. Now remember, if we ever had to verify this and do a left side, right side check, we'd need to take our values and substitute it in both equations to make sure that we get the correct results. Oops, let's say, and the smaller number is 5. There we go. So those are number problems. So we had combination problems, which was a combination of items and finding the relationship between those items. And then we had number problems, which is a combination of just simply numbers and finding the relationships between those numbers, determining what those numbers actually are. Now we get into the last type of problem for the day, and these are what we call money or investment type problems. So this one is probably more real world than any of the other ones so far. So we have to really stretch our mind to really wrap everything around, wrap our knowledge around everything here. So I know many of you may not know what CDs or DVDs are. CDs are for listening to music back in like the 90s and early 2000s. And DVDs are movies on a disc. Not quite a Blu-ray. Definitely not the same quality, but solves the same problem here. So let's read our problem. So money investment type problem. A store sells CDs for $9 each and DVDs for $11 each. Okay. The store clerk sells a total of $204 worth of CDs and DVDs. If she sells 20 items altogether, how many of each item did she sell? So that last part of the statement kind of gives away what we're trying to calculate here. We're trying to calculate the number of each type of item, how many of each item. So our unknown values, our x and our y, are going to be the number of CDs sold and the number of DVDs sold. Okay, so let's do that first. So let's say let x represent the number of CDs sold. CD stands for compact disc. Oops, CD sold. And y is going to be the number of DVDs. I think it's digital video display or something like that, but don't quote me on that one. DVDs sold. And I'm pretty sure I don't need an apostrophe on there, but that's okay. All right. So we now have to look at this. We know x and y represents this unknown value, but now we have to look at our problem here and say, well, how can I create an equation of here? Well, we know this last piece is the easiest piece. if she sells 20 items all together. So that means if we combine the number of CDs plus the number of DVDs, we get 20. So let's use that one first. That's a nice easy one. So X plus Y is equal to 20. Now, this is what separates this type of problem. The next piece separates this type of problem from all the other problems. What we have to do is we have to look at the fact that, yes, we have a certain number of items, but each one of these items has a value. Each CD is $9. Each DVD is $11. So that means if I bought one of each, it'd be 9 plus 11, it'd be $20. If I bought 2 CDs, that'd be $18. And if I bought 1 DVD, so that'd be 2 CDs plus 1 DVD, that'd be 18 plus 11. So that'd be $29. So that's really what we're doing here. We're saying, well, if I combined all of the CDs and DVDs combined and I looked at my receipt, the bill would be for $204. So that means the combined value of all the CDs plus the combined value of all the DVDs gives me $204. Okay. So let's think about what that actually means. So that means I have X numbers of CDs where each one is $9. So that means I have 9X. $9 times X. And I have $11 for each DVD. If I combine that, $11 for each DVD, and we do the math together, we're going to end up with $204. Okay. 9X plus 11Y equals 204. Can we solve this easily? Well, we've got a couple choices here. We can use, we can rearrange, we could do substitution, or we could modify things around and do elimination. I think in this case, it'd probably be easier to do elimination than it would be substitution. The problem is we have to modify one of our equations. So the easiest one to modify is going to be equation 1. So let's take equation 1. And let's say we want to get rid of the x's. So that means I need to get a coefficient of 9 in front of my x up in equation 1. So I'm going to multiply equation 1 by 9. Okay. So equation 3 is going to be 9x plus 9y equals 20 times 9, which is 180. So now we need to, well, we got two 9s and they're both the same sign, so we need to subtract. 9x minus 9x, gone. 11y minus 9y, well, that's 2y. And 204 minus 180 is 24. So that means y is equal to 12. So we just figured out that we bought 12 DVDs. Okay. So now we have this number. Let's substitute it back. Obviously, the easiest equation here is equation number 1. So we're going to say sub y into equation 1, and we're going to try and find x. We're going to try and find the number of CDs we bought. So in this case, so we have x plus y, which is 12. Let me just fix that. Is equal to 20. Bring the 12 over to the other side, and we have x is equal to 8. So what that means is we bought 8 CDs and 12 DVDs, a combined total of 20 items. 8 plus 12 is 20. And if you did the math and multiplied these through, you would end up with $204. 8 times $9 plus 12 times $11, and we get $204. Okay, so therefore statement time. So therefore, 8 CDs and 12 DVDs were sold. Okay, so this is our first money and investment problem. They don't always look exactly like this, but they will always be related back to money. So we're going to do a few examples of these because you're going to see different combinations of them. Okay, so let's go down to the next page. I know this is a longer lesson than we're used to, but this one's got a lot more detail. A little too far there. Okay, so example number 6. SLSS, so Stephen Lewis Secondary School, has a buy-in basketball game during period 4. So that means we can buy into the basketball game and get out of class. So SLSS has a buy-in basketball game during period 4. They charge $2 for students and $4 for teachers. Okay, that doesn't seem fair to me, but what do I know? They made a total of $288, and 132 people attended the event. how many students and teachers were at the game. This is quite literally the exact same question we just saw. If you combine the text for these and just change the numbers, oh, that was a little far. If you combine the text for these and look at the text of these, this is the exact same question. We have a price for one object, a price for the second object, and we know that we made a certain amount of money. We have a price for one object and a price for the other object, and they made a certain amount of money. We are also told how many total of the items we have. In the first one, we had exactly 20 items, and this time we have 132 items. So we're going to follow the exact same pattern. It's the same question. They just swapped out the numbers. So let's try it. So first up, we're going to say, let's let X represent the number of students at the game. Let's X represent the number of students at the game, which means Y is the number. Oops. I don't think I have that. Can I erase there? No, I can't erase. Seeing what I'm capable of doing with my little pen here. Not as much. So the number of students at the game. And Y will be the number of teachers at the game. Okay, so now we got to come up with our equations. Equation number 1. Let's do them in opposite order this time, because then I won't have to. No, we'll do it again. We'll keep it the same way. So in this case, the total number of people is 132. So that means if I combine all the teachers with all the students, I get 132. So that just means X plus Y is equal to 132. Number 2. Again, it's the exact same problem as last time. How much for the first item? Well, the first item is $2. So I have 2 times the number of students I have, plus $4 times the number of teachers I have, is worth a total of $288. Exact same problem as before. We don't have an easy system here, so what we have to do is we got to modify one of the equations. So we'll get rid of X again, which means we got to double the first equation. So we're going to bring this down. Times it by 2, and this is going to be equation 3. And we're going to take this, oops, where's my eraser? And so we have 2 times X, which is just 2X, and we have 2 times Y, which is 2Y, and we have 2 times 132, which is 264. Now we're going to subtract these. Why are we subtracting? Because we have the same coefficient and the same sign. 2x minus 2x, gone. 4y minus 2y, that is 2y. And 288 minus 264, that is 24. If my math, yep, 24. I had to check my math there. And of course, when we divide both sides by 2, we end up with y is equal to 12. That's just coincidentally the same as last time. Don't get used to it. Okay. I just realized that I'm going to scroll up for a second because I'm pretty sure I forgot to do something. The same thing that I forgot to do here, which is to write out what I did, which is 2 minus 3. Where did I put that? Minus 3. I think I forgot to do that on the previous problem. I did. So in this case, we have 2 minus 3. Okay, let's go back down. Oh, I put that in the wrong spot. It's okay to fix. Down here we have 2 minus 3. Alrighty, so we have our value for y. Let's go get x. We're going to substitute our y into equation 1 because it's the easiest, and we're going to find x. I know my x's sometimes look like y. Sorry about that. So x plus y, which is 12, is equal to 24. So that means x is, 132. What was I looking at? Where did my mouse go? There it is. Got to fix that. Sorry. Let's bring that back. Equals 132. So when we subtract 12 from 132, we end up with 120. Wow. That makes sense when you think about it from a school's perspective, because what that means is x, which is the number of students. That means, therefore, there were 120 students, and 12 teachers at the game. Okay, so those two were exactly the same. Let's modify it a little bit. So remember, these types of problems are called money and investment problems. We haven't done any investment. That was straight money. Let's look at some investments now. So investments are usually going to involve some form of percentages. We have to remember how to rewrite percentages as decimals. So for example, in this question, we have a 3% and a 7%. 3% is the same thing as saying 3 over 100, because it's 3 out of 100%. When you do that math, you get 0.03. All right? 7% is going to be similar. It's going to be 0.07. So I'm just going to write 0.03 here. I'm going to write 0.07 here, just so we can keep that in mind as we work going forward. All right, let's read the question. So John invested a total of $750 in 2 accounts, each paying 3% and 7% in interest respectively. So that means the first account paid 3% and the second account paid 7%. If John made a total of $28.50 in interest, how much money did he invest in each account? So again, there's that question. That question at the end that's telling us exactly what the unknown values are. So let's say let X represent the amount invested at 3%. That's the worst 3 ever. 3%. And Y will be the amount invested at 7%. Okay, so now we got to come up with the equations. So first of all, we know that John invested a total of $750. Oh, that's a nice easy one for us again. That means if we add up all the amount invested at 3% and all the amount invested at 7%, that gives us $750. That's a nice one. So we'll just write that one out. X plus Y is equal to $750. That's how much money he invested. However, how much interest did he make? That's the key. So this is similar to our previous question where we're saying, well, we have some amount of X and we have some amount of Y, and that earned a total amount of money, which was $28.50. Now the question is how much of X and how much of Y? So last time it was all about how much each was worth. In this case, it's how much interest was earned. So we're going to say, well, the first one was at 0.03. And the second was 0.07. Sorry, I guess that's a little small there. Let me write that a little bit bigger. So plus 0.07y. So 3% times the amount invested at X plus 7% times the amount invested at Y is exactly $28.50 of earned interest. So we do the same thing we've always done. We have to solve. Now, there's no easy numbers here, not really at all. We could isolate and then substitute, but it's probably easier to get these things to line up and have numbers that we can actually work with. So what we're going to do is we're going to force both of these equations, so this is equation 2, force both of these equations to be something a little bit easier to work with. So let's make sure that equation number 2 has nothing but whole numbers. So what we're going to do is we're going to take equation number 2. Now to get rid of these decimals, we need to shift that decimal place a couple times. We're going to shift it twice, which means we need to multiply this entire equation by 100. Whoa, okay. So we're going to multiply this entire equation by 100. So 0.03 times 100 is just 3. This is equation 3, by the way. So 3x plus 0.07 times 100 is just 7y. And now 2850 times 100, we got to move that decimal place twice, is $2,850. Okay. So that's great, but equation number 1 still doesn't have a 3 or a 7. So let's take this one. Whoosh, you're going to be equation number 4. And we got to get u to a 3x. So we're going to multiply u by 3. So x times 3, that's 3x. Y times 3, that's 3y. And 750 times 3, that's 2250. Okay. We got to do some math. What do we got here? So we have two of the same coefficient on x, and they're the same sign, which means we need to subtract. So that means we're doing 3 minus 4. Okay. So we have 3 minus 3, gone. 7 minus 3, well, that's 4y. 2850 minus 2250 is exactly 600. Okay. So y is going to be equal to $150. What that tells us is that John invested exactly $150 at 7%. But now we got to figure out how much he invested at 3%. We're going to take this number and we're going to substitute y into equation 1 because that's definitely the easiest equation. And our goal is to find x. So we just have x plus y, which is 150, is equal to 750. So x is equal to 600. And that's the whole thing. So we need our therefore statement. Therefore, the amount invested at 3% is $600. So therefore, John invested $600. You know what? We better use our dollar sign here. Proper format. $600 at 3% and $150 at 7%. There is our final statement. Okay. So it's really just the same problem again, but now we're just looking at the numbers a little bit differently because they're percentages instead of just simply quantities. It's some percentage of it. Okay, let's go to the last question. Again, long video. Sorry about that. So the last question is basically the same thing as the previous one. Just need a little bit more space here to write all this. Pardon me. All right, so Miss J, she invested $8,000 in two accounts. Oh, this is sounding familiar again. One account is paying 4.5%. That's another way of saying that is 0.045. Okay. And the other account is paying 6%. Well, that's the same thing as saying 0.06. How much money did Miss J invest in each account to make a total of $457.50 in interest? All right, we have all the information we need. And again, this is the exact same problem as last time. So there's two accounts, and we need to figure out exactly how much was invested in each account. That's our goal. So let's say let X represent the amount invested at 4.5%. 4.5%. And Y is going to be the amount invested at 6%. Okay, now we got to build our equations. First equation, number 1. What's the easy one? The easy one is we know that she invested a total of $8,000 in these two accounts. So if we sum up the amount in each account, we get 8,000. So we have X plus Y is equal to 8,000. Second equation. Now here, this is the same thing as before. We know that how much it's earning, $457.50. So if we take the 4.5% multiplied by the amount for the X account and 6% multiplied by the amount in the Y account, then that will give us $457.50 of earned interest. So we have 0.45 X plus 0.06 Y is equal to $457.50. So we're into the exact same conundrum as last time. We need to make sure that these are whole numbers. We don't have to, but it sure would make life a lot easier in order to solve this problem. So in this case, the 0.045 That one's not as friendly. So we're going to try and get rid of y this time for a change. I know we don't do that very often, but we're definitely going to do that this time, which means we need to get this y and this y to match. So let's get rid of the decimals here. So let's multiply this whole equation by 100, and we'll multiply the top equation by 6. So let's do that first. So first up, we're going to multiply this one by 100. So this is going to be equation 3. So 0.045 times 100, that means the decimal place moves twice. So we still have 4.5. My whole thing is kind of getting messed up on me here. 4.5x plus, move the decimal place twice, we get 6y is equal to, decimal place gets moved twice again. Woohoo, it's a big one. 45,750. Well, that's a big one. And now we need to get equation number 1 to have the same coefficient on y. So that means we need to multiply the equation number 1 by 6. So we're going to take this guy. Oops, stop selecting stuff. We're going to take this thing, bring it all the way around. We're going to multiply this one by 6. So that means equation number 4 is going to have 6x plus 6y is equal to 48,000. 6 times 8,000 is 48,000. Now, our x's don't match, but our y's do, and they're the same sign. So we have to subtract. So we're going to take this whole thing, and we're going to subtract. And what are we subtracting? We're doing 3 minus 4. So 4.5 minus 6, that's going to give us negative 1, or it's going to give us negative 1.5. So negative 1.5x. 6 minus 6, that just goes away. And now we have 45,750 minus 48,000. That's going to give us negative 2,250. Well, when we divide both sides by negative 1.5, the negative is going to go away. And we end up with a nice number, which is just x is equal to 1,500. That actually turned out pretty nicely. Okay. So now that is the amount invested at 4.5%. But we still need to figure out how much was invested at 6%. So we're going to take this number, sub x. We're going to sub it into the easiest equation, which is, of course, equation number 1. And we're going to find y this time. So we have x, which is 1,500, plus y is equal to 8,000. Subtract both sides by 1,500, so we end up with y is equal to 6,500. So what does that mean? It means they invested 1,500 at 4.5% and 6,500 at 6%. So therefore, Miss J invested $1,500, don't forget your dollar sign, at 4.5% and $6,500 at 6%. And that is our money and investment problems. We got 2 more types of problems coming in the next lesson, but we'll save that for later. Good luck.